Hi, I'm Ken Black. Welcome to Business Statistics for Contemporary Decision Making. Today we're going to study when to use what technique in estimating parameters and testing hypotheses. Probably by now in this course, you're either in the second semester or the second half of the semester, and you will begin to be confronted with various techniques that we use to construct confidence intervals or test hypotheses. And one of the real daunting tasks for you will be to sort out the various techniques, to begin to understand the big picture, and to be able to see the forest for the trees. To assist you in pulling this together and helping you to see the big picture and to see how the various techniques fit in the big picture, we want to learn how to construct a tree diagram that pulls the various techniques together. Let's talk about the branch of the decision tree that deals with hypothesis testing. In testing hypotheses in this particular course, we want to first focus on how many samples are we taking. The possibilities are 1 sample, 2 samples, or greater than or equal to 3 samples. The 1 sample hypothesis testing techniques are presented in Chapter 9. The 2 sample hypothesis testing techniques are presented in Chapters 10 and 13, depending on the level of data. 3 or more samples in hypothesis tests are presented in Chapters 11 and Chapter 13. What does the decision tree look like when we're testing hypotheses using a single sample? Well, our options are we testing hypotheses about a mean? Are we testing hypotheses about a proportion? Or are we testing hypotheses about a variance? If we're testing hypotheses about the mean, then we have to be concerned about is sigma known or is sigma unknown. In the 1 sample hypothesis test about the single mean, when sigma is known, we can use the z-test, and that is presented in the text in section 9.2. If we're testing hypotheses about the mean and sigma is unknown, then we will use the t-statistic, and this information is presented in section 9.3. If we're testing hypotheses about a single proportion using 1 sample, then we will use the z-test, and this particular technique is presented in section 9.4 of the book. And if we're testing hypotheses about a single population variance using 1 sample, we will use the chi-square technique, and this technique is presented in section 9.5. Now let's talk about our decision tree when we're using 2 samples to test hypotheses. When we're using 2 samples to test hypotheses, we have some options to consider. Are we testing hypotheses about means? Are we testing hypotheses about proportions? Or are we testing hypotheses about variances? If we're testing hypotheses about the mean, our first decision is, do we have independent samples or do we have dependent samples? Once we determine this, we have to determine what level of data measurement do we have. We can have either interval ratio level data, which are analyzed the same way, or we can have ordinal level data, which are analyzed a different way. So if we are testing hypotheses about the difference of 2 population means, the samples are independent, and we have interval ratio level data, we have one more thing we must consider. Are the population variances known, or are the population variances unknown? If the population variances are known, and we're testing the differences of 2 means for independent samples, interval ratio level data, we will use the z-test, and these techniques are presented in section 10.1. If we have interval ratio level data from independent samples and we're testing the difference in 2 means and the population variances are unknown, we will use the t statistic, and these techniques are presented in section 10.2. If, however, we're testing the difference in two population means, we have independent samples, but we have ordinal level data, then we're going to have to use a non-parametric technique, and these are presented in Chapter 13. In this particular case, we will use the Mann-Whitney U test, and this is presented in section 13.2. If we're testing the difference in two population means, and we have dependent samples, then we have to determine if we have interval ratio level data or ordinal data. If we have ordinal data and our two samples are dependent, once again, we're going to have to go to a non-parametric statistic. A statistic called the Wilcoxon matched pair statistic, and this is presented in section 13.3. If we have, however, a hypothesis test about two means and the samples are dependent, but we have interval ratio level data, then we're back in Chapter 10. We're going to use the t statistic, and this particular statistic is presented in section 10.3. If we're analyzing the difference in two population proportions, we use the z statistic, and this statistic is presented in section 10.4. If we're analyzing two population variances, we use an F statistic, and this statistic is presented in section 10.5. In conducting hypothesis tests with three or more samples, we're now using some techniques referred to as analysis of variance, and we're getting into more what they call design of experiments, presented in our text in chapters 11 and chapter 13. So let's see how this would be formulated into our decision tree. We actually start off with three branches, dependent upon how many independent variables you have, and if you have blocking variables and other decision matters such as that. If you have one independent variable, then the next decision would be what level of data do you have? If you have interval ratio level data, then you're going to perform a one-way ANOVA or a one-way analysis of variance. And these techniques are presented in the text in section 11.2. If, on the other hand, you have ordinal level data, then you're going to be using a non-parametric version of the one-way statistic, or the Kruskal-Wallis statistical procedure. And the Kruskal-Wallis techniques are presented in section 13.4 in the non-parametric chapter. Suppose, on the other hand, though, you have one independent variable plus you're going to use a blocking variable. As before, we have a decision with regard to the level of data that we have. If we have interval ratio level data, then we're going to use the randomized block design featured in the text in section 11.4. If, on the other hand, you have one independent variable and a blocking variable, but you have ordinal level data, then you're going to use the Friedman technique, which is a non-parametric test for blocking, and it is presented in section 13.5. Now, suppose you have two independent variables, then the only option we have in our text is a well-known technique known as two-way ANOVA. And two-way ANOVA is presented in the text in section 11.5. To summarize, in constructing a decision tree to help us determine what statistical technique to use, we can ask ourselves 5 questions. The first question is, are we estimating, thereby constructing a confidence interval, or are we testing, thereby conducting a hypothesis test? The second question is, how many samples are we taking? The number of samples you take is driven by how many population parameters you're estimating or testing. Commonly, in this course, we study using 1 sample, 2 samples, or 3 or more samples. And another critical question that we ask ourselves in constructing this tree is, are we estimating or testing a mean, a proportion, or a variance. And if we are estimating means or conducting hypothesis tests about means, then we need to ask two more questions. The first question is sigma known, which usually results in a z statistic, or is sigma unknown, in which case we use the sample standard deviation and we probably will be doing a t statistic. And the other question, if we're estimating means or testing means, is what level of data do we have?